So we've talked about other forms of motivation, and we could kind of put sex as a form of motivation, but it's a little different because if you don't eat, you could die. If you don't drink anything, you can die. But if you don't engage in sexual intercourse, obviously you will not die. So sexual intercourse is related to the survival of the species, not the individual. But we could look at some correlations or some similarities, I should say, between the two, between hunger and thirst and as a form of motivation and sex as a form of motivation. We'll talk in terms of arousal and satiation. We'll talk about hormonal control, and we'll talk about the specific areas of the brain that control your arousal and satiation. A groundbreaking research study was conducted by actually William Masters and Johnson in the 1960s, and they actually, and this is the first time that's ever been done with humans. Back then it was very controversial, but they actually charted what the typical response time looks like, or the phases of sexual response. And it entails an excitement phase for both males and females, a plateau phase where excitement kind of levels off, an orgasm phase, a resolution phase, and a refractory phase. However, the refractory phase is only for males. And then they actually talked about the Coolidge effect, which is mostly for males too, which is when there's a new partner introduced, the refractory phase might be shortened a bit. We can also talk about sex hormones, which are androgen, also known as testosterone, and that's found more heavily in men, about 15 to 20 times more heavily in men. Estrogen, which is primarily found in females, but you will find it in males in a smaller amount, and progesterone, which is also found primarily in females, but it's also produced by the males as well. And we know that these hormones drive our behavior because from studies of animals and people, by the way, where they castrate a male, for example, and they noticed, well, when you castrate a male, you remove the major source of sex hormones, and they notice a loss of sexual motivation. And this has been done in some rare cases, and even to control criminal behavior. There's also two important brain structures we could talk about, which is the medial preoptic area, MPOA, of the hypothalamus. And this has been shown to be active during copulation. It also appears to be responsible for more of sexual performance than sexual drive, which has been seen in numerous animals. And the other area that's important is the medial amygdala, and this is found in the temporal lobe, and it's responsible for sexual behavior in both sexes, so both males and females. It also plays a role in emotions and aggression, well, the amygdala does, which we'll talk a little bit later on in another lecture. So what the medial amygdala does is it responds to sexually exciting stimuli. So for example, if you're in the presence of a potential sex partner, this is the part of the brain that activates, and stimulation causes the release of actual dopamine in these areas. Other parts of the brain that are important when we talk about sexual motivation are the paraventricular nucleus, or PVN, and the sexually dimorphic nucleus, or SDN, of the MPOA. Now, the sexually dimorphic nucleus, again, is located in the preoptic area, And interestingly enough, it's 3 or 4 times larger in males. Well, we can talk about male rats, usually where most of the research is, than in females. And it seems to be related to sexual activity. We've also noted in research that when you destroy this area, there is a decreased amount of sexual activity in males. I also want to note the ventromedial hypothalamus. Now, this area is important for males and females, but it seems to be more important for females, and its role is really related to sexual interest. And fascinating is if you ablate this or destroy it in females, if you destroy this area or ablate it, then females will be less likely to be open to male advances, actually. We could look at how the release of dopamine in the brain increases sexual activity and is linked to orgasmic activity as well. Another hormone we could look at is serotonin, and research has kind of shown that during ejaculation, serotonin increases in the lateral hypothalamus. And interestingly enough, SSRIs, or drugs that act on serotonin, actually impair sexual ability and orgasm. The other thing of note is humans can distinguish 10,000 plus odors from only a few hundred receptors. And they've taken this remarkable sense of olfactory that we have, and they've done t-shirt studies, and these studies indicate that people can distinguish family members from others based on this genetically determined odor. Another point is the major histocompatibility complex, or MHC, differences. Women prefer odors of men who differ in MHC. Couples with similar MHC are less fertile, and when they have dissimilar MHCs, there's much greater sexual satisfaction.